Hi guys! Today we're starting chapter 2. Now we already started chapter 2 a little bit during our live session where we learned about finding the domain and range given a graph. We will be continuing our notes on domain and range, and we'll also learn in this video about relations and functions. Make sure to write down the title and you can continue with your notes from class. Our notes from class started with domain and range, so you may have already written this down. If you did not take notes during class, please write this down right now. We learned today that domain is the set of all x coordinates, and that the range is the set of all y coordinates. When given a continuous graph, we write those as an inequality, saying that it starts here and it ends here, and includes all the numbers in between. But not everything today will be a graph. Today, we're dealing with something called relations. In relations, the most basic definition of it is that it is a set of ordered pairs. So we will not just be dealing with graph pictures, we also will have a set of ordered pairs, so just a bunch of ordered pairs written in a row. We might take those ordered pairs and instead of writing in a row, we might write them in a table, so we'll stack them on top of each other. We could draw a mapping, and I'll teach you what that is today if you don't know. Or technically a graph is just like an infinite amount of ordered pairs, right? Every single spot on the graph is considered an ordered pair. So these are all called relations. When you're writing the domain and range of ordered pairs, a table, or a map, you're basically going to write a list of numbers. When you're writing that list, if there's a number that repeats, don't write it twice, only write it once. And it is best if you write your numbers in numerical order. Now you can have numbers that are existing in the domain and also existing in the range. Then you would write it twice, once in the domain and once in the range. You just don't want to repeat it twice in the domain or repeat it twice in the range. The other thing we're learning about today is what a function is. So one of the questions I will ask you is this relation a function? The technical definition of a function is a relation where each x is assigned only one y. Essentially, what that means for us is that you can't have a repeating x. If you have the same number for x written twice, that means that it is not a function because that number has two letter y's assigned to it, and that's not good. All right, we're going to do one example of each ordered pairs table map, and I'll show you how to figure out if a graph is a function. Here we're starting with a set of ordered pairs. Please notice that the ordered pairs are written with parentheses, and I've grouped them all together with squiggly brackets. That's holding them together and making them a relation. To find the domain, I'm literally just going to list out all of the x's. I do want to go in numerical order, so looking at them, I see a 2, a 1, a 0, and a second 1. I'm going to start with the 0 because that's the smallest. 0, 1. I'm not going to repeat the 1, and then I'll write 2. So my domain is 0, 1, 2. When you're writing your domain and you're grouping it together, you also want to use the curly brackets. You don't want to use parentheses because parentheses imply an ordered pair, or in this case, it would be an ordered triple. And so you don't want to use just regular parentheses, definitely squiggly brackets. If you can't draw the curly braces, just draw a squiggle line, something that's not a regular parentheses. Looking at my range, I'm going to look at all my y numbers. Those are the second numbers in the ordered pair. If I start at the end, I can start with the smallest. So 1, 2, 3, and 4. Those are all my ranges, my y numbers. Again, in the curly brackets. It's okay to have the same number in the domain and the range. It's not an issue. The final thing we have to do is tell if this is a function. So to figure out if it's a function, we said that every x has to be assigned only one letter y. And essentially, we're just looking for repeating x's. Now, as I was writing my domain, I did notice that I had a repeating x. I have this number 1 is written twice. That means that this is not a function because the number 1 is attached to the number 3, and the number 1 is also attached to the number 1. That means that this x is not attached to only one y. It's attached to multiple y's. And that's what makes it not a function, when an x has multiple y values attached to it. All right, let's move on to our next type of relation, which is a mapping. So this is a mapping, and if you've not seen these before, essentially it's already listed out the domain and range for you. It's actually really nice. So what they did was they put all of the X's in the first circle for you, and they put all of the Y's in the second circle for you. And so it's really cool because that just means that like that first circle is your domain, and the second circle is your range. And so you don't even have to really think about it too much. It's just the first one's domain, second one's range. Each of these arrows represents an ordered pair. So if we follow an arrow, we could actually like convert this into ordered pairs instead. That first arrow is 1, 0. If we follow this second arrow, that is telling us that it's an ordered pair 2, 0, right? So you can tell how many ordered pairs a mapping has based on how many arrows it has. So this one has a total of 4 ordered pairs. And if you want to change it all to ordered pairs because that's easier to work with, that's totally acceptable. So here's what it looks like as ordered pairs. Now, from the ordered pairs, I can also tell very easily that this is a function. It is a function because none of my x's are repeating. Now, I don't care about my y's. My y's can repeat, and this one, it was the same letter y for every single one, and that's fine. I'm really just concerned with my letter x's. So since each of my x's is unique, that means that this is a function. If you want to look at the mapping instead to figure it out, you can tell that this is a function because each number in the first circle has only one arrow going out of it. If one of the numbers had 2 arrows going out of it, that would be not a function. So you're looking at how many arrows are attached to the numbers in the first circle. And this is a mapping. For a table, it's basically just the same as ordered pairs. It's just written vertically instead of horizontally. So I don't have an example of a table. All right. For our final thing that we need to learn today, we need to learn if a graph is a function. Now, we already learned how to do domain and range for a graph. And so again, we're just focusing on, is it a function? For is it a function, you're going to do what's called the vertical line test. The vertical line test says, if you draw vertical lines are going up and down. And if every single vertical line only touches the graph in one spot, then it is a function. And if it touches in multiple places, then it's not a function. So let's take a look at that first picture. Every vertical line that I draw is only touching the picture in one spot. This vertical line is only touching here. This one is only touching here. This one is only touching here. When each vertical line is only touching in one spot, that is a function. So this one would be yes. For my other scenario, my second picture, when I draw a vertical line anywhere in the problem, doesn't matter. If there's anywhere in the question where I can draw a vertical line and it touches in 2 spots, that makes it not a function. Now, the reason why is if I were to write ordered pairs, and I'm going to shift that line over a little bit so I can write actual like nice numbers maybe. So if I look at, maybe even go here, let's draw the vertical line here. If I look at where it's touching here and where it's touching down here, that first ordered pair is 1, 1, and that second ordered pair is 1, -1. And we talked earlier today about how if you have repeating x's, then it's not a function. So the fact that you could draw a vertical line and it touches twice means that it's touching 2 different spots on the same letter x. And that's what makes it not a function. And so that one is no. This concludes our only video for today. You should be able to do your homework. Don't forget you also have Delta Math.